In computer engineering and in programming language implementations, a belt machine is a real or emulated computer that uses a FIFO queue rather than individual machine registers to evaluate each sub-expression in the program. A belt computer is programmed with an instruction set that specifies arguments explicitly but results implicitly. The common alternative to belt machines are register machines, in which each instruction explicitly names the specific registers to use for operand argument and result locations. Belt machines are related to stack machines, which specify both arguments and results implicitly using a push-down stack. Other alternatives are accumulator machines, which have only one visible general-purpose temp register, and memory-to-memory machines, which have no visible temp registers. A belt machine implements temporary storage with a fixed-length FIFO queue, or belt by analogy to a conveyor belt. The operands of the arithmetic logic units, ALUs, and other functional units may be taken from any position on the belt, and the result from the computation is dropped, stored, in the front position of the belt, advancing the belt to make room. As the belt is fixed length, drops in the front are matched by older operands falling off the back. Pushed off operands become inaccessible and must be explicitly saved if they are still needed for later computation. Most operations of the instruction set work only with data on the belt, not on data registers or main memory cells. For a typical instruction like add, both argument operands come from explicitly named positions on the belt, and the result is dropped on the front, ready for the next instruction. Most belt instructions are encoded as just an opcode and two belt positions, with no additional fields to specify a result register, memory address, or literal constant. This encoding is easily extended to richer operations with more than two inputs or more than one result. All accessing of program variables in main memory RAM is segregated into separate load or store instructions containing one memory address or some way to calculate that address from belt operands. All belt machines have variants of the load/store opcodes for accessing local variables and the heap. This can be by offsets from a pointer on the belt, or by offsets from various special purpose base registers. Similarly, there will be instructions to branch to an address taken from the belt, in addition to branches relative to the program counter.